Okay. So, can you say anybody how can we solve this problem? Okay. So, three equipotential surfaces are given 10 volts, 8 volts, and 6 volts. So, what is meant by equipotential surface? Equipotential surface means what? So, everywhere on this surface, same amount of potential will be existing. That is the meaning of this one. No? For example, throughout this line, here also it is 10 volts, here also it is 10 volts, here also it is 10 volts, here it is 8 volts, 8 volts, 8 volts, 8 volts, 6 volts, 6 volts, 6 volts, and 6 volts. So, everywhere on this surface, same amount of potential will be existing. Clear? Then how can you draw the approximate field lines? Field lines means what? How electric lines are traveling from throughout this equipotential surface, or how can you draw the lines of electric field? Electric field lines, how can you draw? Anybody? How can you draw? Ma? Come on. First one, how can you draw electric field lines approximately? Already we have studied one property, no? What is the property we have studied? Electric field is always perpendicular to equipotential surface. Perpendicular to equipotential surface. This is what we have discussed previously, no? Clear, no? Ma? So therefore, what is the meaning of this one? So here the direction of electric field will be like this. Clear? And here the direction of electric field will be like this, perpendicular. Clear? So this will be the direction of electric field. And here the direction of electric field will be like this. Clear? So this is the approximate direction of electric field. Clear? So therefore, if you join all these points, approximately this will be the direction of electric field. Clear? Ma? This is E direction. So why we have drawn like this? Because everywhere electric field should be perpendicular to equipotential surface. Okay, ma? So first one we have calculated. Then what he is asking, and find electric field at a point A where the distance between equipotential surface is 4 centimeter. Clear, ma? So here distance between two equipotential surfaces is 4 centimeter. Here I want to calculate the strength of electric field. How can I calculate? How can I calculate, ma? See, ma, electric field is strength direction. Why I have drawn in this direction? Why can't I draw in this direction? First of all, can you say answer for this one? Electric field, I have drawn direction downwards. Why can't I draw in upwards direction? Why can't I draw this one in upward direction? So this direction correct, or this direction is correct? Which direction is correct? Come on. This one is correct. Why? Why? Because as you move in the direction of electric field, potential should decrease, no? That is the meaning of E is equals to minus dV by dr. E is equals to minus dV by dr means what? If you move in the direction of electric field, potential should decrease. Potential is decreasing, no? 10, 8, 6. So definitely this is the direction of electric field. This is not the direction of electric field. Are you able to understand, ma? So this is second property. Then at this point, here I want to find out electric field strength. How can I calculate? 1 minute, ma. Okay, ma. So therefore, E is equals to minus dV divided by dr. Clear? So if I calculate the magnitude of electric field, so what is the change in potential from this point to this point? Change in potential is 6 and 8. 2 volts is the change in potential. Clear, ma? So 2 divided by distance is how much? Distance between them is 4 centimeters. So 0.5 volts per meter. This will be the magnitude of electric field at this point. Are you able to understand, ma? So 0.5 volts per not meter, volts per centimeter. Because here data is given in centimeters, no? So that is the electric field at that point. Are you able to understand, ma, all of you? That's all very simple. Okay. So V is equals to x into y square minus 4x square. Then we are supposed to find out the components of electric field at a point. What is meant by components of electric field at a point, ma? What is the meaning of this one? Components of electric field at a point means what? Components means x component and y component. That is the meaning of this one, no? X component and y component. So, first of all, how can we say that electric field has two components? How can we say that electric field has two components? How can I say that? Because here you can look at the equation of potential, no? V is equals to x into y square minus 4x square. So, when you see this relation, what do you understand? When we see this relation, we should understand that potential is varying across x-axis also. Similarly, potential is varying along y-axis also. That is the meaning of this one, Nama. As x value changes, potential changes. Similarly, as y value changes, then also potential will change. Clear? So, therefore, what is the point here? We have to write potential is changing. Potential is changing along both x and y axis. Clear ma? Potential is changing along x axis also, potential is changing along y axis also. So potential will change in which direction? Potential will change only in the direction of electric field or in opposite direction to the direction of electric field. That's all, Dhamma. For example, if this is the direction of electric field, clear? Now if you are moving from here to here, then potential will change. Or if you are moving in opposite direction, then also potential will change. But if you are moving perpendicular to electric field, then potential will never change. Already we have studied this one, no? So, for example, this is here potential is V1 and here potential is V2. Then what is the relation between V1 and V2? What is the relation between V1 and V2? Come on. They are equal. V1 is definitely equal to V2. What is the reason? Because only if we move in the direction of electric field or in opposite direction of electric field, then only potential will change. And potentials are equal when we are perpendicular, when we are moving perpendicular to the electric field. Because these two, they will become equipotential surfaces. No? Already we have studied that electric field is always perpendicular to equipotential surface. So definitely this surface will behave like a equipotential surface. Clear, ma? So in many methods we can explain why here potentials are equal. So this total surface is an equipotential surface. It means if I want to take a test charge from this position to this position, then work done will be 0. Why work done will be 0? Because both the points there are present at same potential. Are you able to understand, ma? Similarly, if potential is changing along x-axis, if potential is changing along x-axis, it means electric field is present along which direction? It means electric field is present along y direction. That is the meaning of this one, Nama. Similarly, if potential is changing along y direction, it means electric field component is present along x-axis also. So potential is varying along x-axis and y-axis. It means electric field is present along both the axes. Electric field is present along x-axis also. Electric field is present along y-axis also. So therefore, total electric field, how can I calculate? Total electric field can be calculated as x I cap plus, or I can write like this. I will write it as Ex I cap plus Ey j cap. What is meant by Ex I cap and Ey j cap? Clear, ma? It means electric field has component along x-axis also, and electric field has component along y-axis also. Clear, ma? Then what is the relation between electric field and the potential difference? E is equals to minus dV divided by dr. This is the relation. This relation I can use in which condition? This relation I can use when potential is changing only along one axis. But here potential is changing along both the axes, no? So therefore I have to take partial differentiation. So E is equals to minus of, so dou V divided by dou X. I have to write like this. Clear, ma? Or I can write minus of dou V divided by dou X. Clear, ma? So dou R dash, dou R I can write this one. So plus dou V divided by dou Y. This is how I have to write. Clear, ma? So partial differentiation of potential along x-axis, partial differentiation of potential along y-axis. Okay. So first of all, make a note up to here. Then you try to differentiate this one with partial differentiation method and see what is the electric field. Now let us see what we can do. Okay. So therefore, this v, how can I write? This v, I can write it as v is equals to xy square minus 4x cube. This is how I can write now. So therefore, E is equals to minus of dou v divided by dou x I cap plus dou v divided by dou y j cap. So first of all, I will calculate Ex dash. What is Ex dash? Minus dou v divided by dou x I cap. Clear now, ma? So therefore, partial differentiation of this potential, total potential with respect to x we are supposed to do here. So minus of dou by dou x of, now what is the total potential? Xy square minus 4x cube. Clear, ma? Now can you say what is the meaning of partial differentiation, ma? Partial differentiation means what? Here I am doing the partial differentiation of potential with respect to x. What is the meaning of this one? Can you see? It means that in this condition only x is a variable. Only x is a variable, y is a constant. That is the meaning of partial differentiation. Are you able to understand, ma? So here if I do partial differentiation of this one first term, y is a constant, no? So y I will take outside. Dou x by dou x is how much? Dou x by dou x is 1. Clear? So therefore minus of, now in this term there is no y term, so 4 3s are 12, so 12x square. Clear, ma? So total, what is the equation I got? Ex dash is equals to, clear, ma? So minus y square plus 12x square I cap. Clear? So minus y square, no need of symbol now here. So 12x square minus y square I cap. Clear, ma? So this is the component of electric field along x-axis. Similarly, how can I calculate the component of electric field along y-axis? Okay. So now I want to calculate Ey. So Ey dash is equals to minus of dou v divided by dou y j cap. Clear, nama? Because unit vector along the y-axis is j cap. So minus of dou divided by dou y, potential is how much? Potential is xy square minus 4x cube j cap. Clear, nama? So minus of, now can you say what is the partial differentiation of xy square? Now x is a constant, no? So x into differentiation of y square is 2y. Clear, ma? So minus partial differentiation of 4x cube is 0. Why? Because 4x cube is a constant in this condition. So therefore Ey dash is equals to how much? Minus 2xy j cap. Clear, ma? So therefore this is the component of electric field along x-axis. This is the component of electric field along y-axis. That is the answer which he is asking, no? That's all. So these are some of the equipotential surfaces which are drawn. Clear, ma? So this equipotential surface, they are making an angle of 30 degrees with respect to positive x-axis, and they are arranged at equal distances 10, 20, 30 and 40. Clear, ma? So these distances are given in centimeters. So how can you calculate the magnitude and the direction of electric field? Okay, ma? First of all, can you say what will be the direction of electric field, ma? Direction of electric field perpendicular to equipotential surface. Clear, ma? So if these are the equipotential surfaces, this will be the direction of electric field. That's all, no? Perpendicular to these equipotential surfaces. Now the question is, electric field is present in this direction or electric field is present in this direction? Out of these two, which one is correct? Out of these two, which one is correct? This direction is correct because, yes, this is correct. Because if we move in the direction of electric field, potential should decrease, no? If I move in the direction of electric field, potential should decrease. So 40, 30, 20 and 10, electric field is decreasing in this direction. Are you able to understand, ma? Okay. So therefore, now how can I calculate magnitude of electric field? Direction we have calculated. Magnitude, how can I calculate? Any idea? Magnitude, how can I calculate? Yes. Clear? So, answer, ma? I too don't know, let us see. Clear, ma? So this 10, I can split this one like this, no, ma, into two components. Are you able to understand? So if this is a 10, this is a 10 cos 30, this one is a 10 sin 30. So 10 sin 30 is in which direction? 10 sin 30 is in which direction? 10 sin 30 is in the direction of electric field only, no, parallel to the direction of electric field. Clear? So therefore, E is equals to minus dV divided by dr. So E, magnitude of electric field, just if I want to calculate, then what is the potential difference between this surface and this surface? Potential difference is 20 minus 10, 10 volts. And dr means which distance we are supposed to take, ma? Perpendicular distance only, no? So perpendicular distance between these two is how much? 10 sin 30. So 10 sin 30. So 10 and 10 gets cancelled. So what is the magnitude of electric field? 1 by sin 30. 1 by sin 30 means what? No, 10 is given in centimeters, no ma? So let us do like this. So dV value is how much? dV value is 10. dr value is 10 into 10 power minus 2 sin 30, because it is given in centimeters, no? So 10 and 10 gets cancelled. So 100 divided by sin 30. So 100 divided by sin 30 value is how much? Sin 30 value is 1 by 2. So magnitude of electric field is how much? It is 200 volts per meter. Clear, ma? 200 volts per meter is our answer. And what is the direction of electric field? This is the direction of electric field. That's all. So this is the given question. So determine the electric field vector. Clear, ma? The potential of this point depends on V is equals to A into x square minus y square. Clear? So potential, how it is changing, that is given. V is equals to A into x square minus y square. So electric field vector, that is E dash, we are supposed to find out. So already we have done some problems based on this one number. Now can you say how can I do this one? Anybody? How can I do this calculation? How? See, by looking at this equation, what do I understand? V is equals to A into x square minus y square. What do you understand from this one? Can you say? We understand that V value is depending on x as well as y also, no? This is what we understand. Potential is changing with respect to x also, it is changing with respect to y also. It means that electric field is present in both vectors. Electric field is present along x-axis. Similarly, electric field is present along y-axis also. So therefore, what I can write? So therefore, E dash can be written as minus dou V divided by dou x I cap minus dou V divided by dou y j cap. This is what we have done previously also, no? So if I partial differentiate this velocity, this potential with respect to x-axis, then I will get electric field along x-axis. Similarly, if I partial differentiate the same potential equation with respect to y, then I will get the equation for electric field along y-axis. That's all, Nama. Now do this calculation. So dou V divided by dou x is how much? So dou by dou x of, can I write it as A into x square minus y square. Clear? So A, if I take common, then differentiation of x square is how much? 2x, and differentiation of y square. Y square is a constant, you know, because we are doing partial differentiation here. So y becomes a constant. Differentiation of y will become 0. So therefore, 2ax is the electric field along x-axis. Clear, ma? Similarly, I should do the partial differentiation of y also, no? So dou v divided by dou y. For this one, how can I do? So again, dou by dou y of potential is again A into x square minus y square. Clear, ma? So now here y is a variable, x is a constant, because we are partial differentiation, no? So therefore A, if I take common, differentiation of x square is 0, differentiation of y square is 2y. So minus 2ay. That's all, no? So therefore, now if I substitute in this relation, so therefore E dash is equals to minus of, so dou v by dou x is how much? So 2ax I cap and minus of 2ay j cap. That is our answer. So therefore electric field is equals to 2 minus 2ax I cap plus 2ay j cap. That is the magnitude of electric field which is existing along both x-axis as well as y-axis. Okay. So this is the given question. So find the field intensity of V is equals to minus kx into y. So electric field intensity we have to find out. Similarly, how electric field is changing with respect to position, that graph also we are supposed to draw. That is the meaning of second question. So can you say, how can I do it? How can I do this calculation? So given potential equation is what? V is equals to minus kx into y. So by looking at this potential equation, again what do you understand? Come on. What do you understand by looking at this equation? Yes, that is the meaning of this one, Nama. So here potential is changing with respect to x-axis also and y-axis also. That is with respect to x and y, potential is changing. It means that electric field is present both along x-axis as well as y-axis also. That's all, Nama. So if potential is changing along x-axis, it means electric field is present along x-axis. If potential is changing along y-axis, it means potential is present along, electric field is present along y-axis also. That is the meaning of this one. Clear? So therefore, E dash, how can I calculate? E dash is equals to minus of, so dou V divided by dou x I cap plus dou V divided by dou y j cap. That's all, Nama. So dou V divided by dou x, how can I calculate? So dou by dou x of potential is how much? Minus kxy. So minus k if I take common. So differentiation of ky I can take common. So dou x by dou x is multiplied by 1. So here we are doing partial differentiation with respect to x, Nama. So k is also a constant, y is also a constant. So both of them I will take outside. So dou x by dou xy value is 1. Similarly, dou v divided by dou y. So therefore, dou by dou x of minus k into xy. Now here what are the constants, can you say? We are doing partial differentiation with respect to y. Now what are the terms which are constant here? Minus kx is a constant. Okay, ma? So minus kx, if I take outside, then dou y by dou y is 1. Clear, ma? So therefore, what is the electric field I got? So therefore, E dash is equals to minus of minus ky I cap minus kx j cap. This is the values which I got now. So minus minus gets cancelled. So electric field is equals to ky I cap plus kx j cap. So this is the amount of electric field which I got. Okay, ma? So up to here it is clear. Now what shall I do? So second question is draw the field pattern of electric field. So how electric field is changing with respect to position, that also we are supposed to draw. Clear? So first of all, make a note up to here. So now let us see how we can draw the field pattern. Okay. So very simple. So first of all, we will try to calculate what is the relation between x and y. If I can find the relation between x and y, then very easily I can say what can be the type of graph that is existing between electric field with respect to x-axis or y-axis. Are you able to understand, ma? So therefore, what is the equation of electric field I got? I got ky I cap plus kx j cap. It means that, for example, this is the total electric field. This electric field I can split into two components, Nama. So one component along x-axis, one component along y-axis. So this I can call it as Ex dash. This is Ey dash. So that is electric field along x-axis is how much? Ky I cap. Electric field along y-axis is how much? Kx j cap. So these are the values of electric field. No? Similarly, if I take slope of this graph, okay. So what is meant by slope of a graph? Slope of a graph is nothing but dy divided by dx. Dy divided by dx, or also you can call it as a tan theta also. This is called slope of a graph, Nama. Clear? So tan theta is what? Dy divided by tan theta, if I take this angle to be theta, then opposite side divided by adjacent side. Opposite side is how much? Kx divided by adjacent side is ky. So therefore, dy by dx is equals to kx divided by ky. So k and k gets cancelled. So therefore, dy by dx is equals to x divided by y. Now if I do the cross multiplication of these two, y dy is equals to x dx. I got a relation up to here. Now integrating on both sides. Clear ma? Integrating on both sides. Why I am integrating? Because I want to calculate a relation between x and y so that I can draw a graph between them. Clear ma? So if I integrate, integration of y dy is how much? Y square by 2 plus c. Integration of x dx is x square by 2 plus c. So this is c1, this I can call it as a c2. Okay. So therefore what I can write? I can write y square by 2 minus x square by 2 is equals to c2 minus c1. c2 minus c1 is a constant. Clear ma? So y square minus x square is also a constant, because this 2 also, if it goes and multiplied with this constant, then that is also a constant. So what is the final relation I got? Final relation which I got is y square minus x square is equals to constant. Clear ma? And what is this equation? This is an equation of parabola. Clear ma? Come on. First of all, make a note up to here. So therefore, this is the equation of a hyperbola. Okay ma? So therefore, if I draw a graph, what will be the type of graph I will get? So I will get approximately this type of graph. Clear ma? So this is the graph which I will get. If I am taking plus x and minus x and plus y, clear? Then this is the shape of the hyperbolic graph. Okay, that's